another problem with related rates. This is on the 2016 exam, number 5. The inside of a funnel of height 10 inches has circular cross sections, as shown in the figure above. At height h, the radius of the funnel is given by this guy, where h is between 0 and 10. Units of r and h are in inches. Find the average value of the radius of the funnel. Okay, so how do we do that? Well, this is the length of the radius. The funnel height is from 0 to 10. Remember the formula for average value of a function? The function is r of h. The radius depends on the height, what height you are at. So the radius is a function of h. So it's just 1 over 10 minus 0, integral from 0 to 10, your r of h dh. Okay? This is no calculator allowed, so you gotta do it by hand. So this constant I pulled out in front, and that's simplified to 1 over 200. Okay? Power rule, fundamental theory of calculus, don't forget your units, inches. Actually, I don't remember, in this one guidelines does the units matter, but always put it. It's my suggestion. Unless you're not good with the units, which you should be, but if you're not confident in units, then maybe leave it off. This one doesn't explicitly say to have your units, but I would just put it. Okay? Part B, find the volume of the funnel. So how do we do that? We gotta treat this R of H like a solid revolution. Okay? So do we use the shell method or the disk method? Disk washer method. I think this would be a disk if so. Which one do we use? Here, we could actually just use the disk method. Okay? You might be tempted to think that since if I draw like my XY axis per se, we're revolving around a vertical axis, so you might be tempted to use the shell method. But actually, if you draw your axis properly, you can even think of it like this. So this is increasing r, right? So my function value is r, and this is h over here as the x, okay? So if we interpret it like that, we could just use the disk method, okay? And what's the disk method? It's just pi r squared, okay? So that's what I wrote right here. Pi r, which is this guy, squared dh. It's from 0 to 10, okay? So again, think of it like this. This is increasing h, this is increasing r, okay? So that's a setup. You're not allowed a calculator, so we gotta do this by hand. 1 over 20 squared is 1 over 400. It's constant, pull it out on the front. Gotta pull this out. Do the power rule, fundamental theory of calculus. Don't bother simplifying. Way too risky. Leave it like this. Don't forget your units, inches cubed. Volume is inches cubed. This was average value of the radius. Radius is in inches. Part A, by the way, okay? And then part C, the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inches per second. At this instant, what is the rate of change of the height of the liquid with respect to time? Lots of words, but you can probably tell, hopefully you can tell, I should say, that is a related rates question. We're going to differentiate this guy with respect to time probably. So let's read it one more time. So it's draining from the bottom. At the instant when a height, so h equals 3, radius of the surface of the liquid is decreasing, so dr dt is decreasing at a rate of 1/5 inches per second, because this is radius decreasing at a rate, so derivative dr dt is 1/5, but with a negative, so negative 1/5, because it's decreasing. Okay, dr dt is minus 1/5. At this instant, what is the rate of change of the height? This is asking for dh dt. Okay, so as I was saying, we probably need to differentiate this with respect to time, which we do, in order to find dh dt. And they give us dr dt, right? So dr dt is 1 over 20 is a constant, leave that alone. Differentiate this, that will be 3, derivative of 3 is 0, sorry, so it will be times 2h, and then dh dt by chain rule, plus differentiation, whatever you want to call it, okay? So they give us dr dt minus 1/5, h is 3, solve for dh dt, okay? You should get minus 2/3. Units are inches per second. H is in inches, t is in units of seconds. 2/3 minus 2/3 inches per second. And that's it for this one. This was pretty standard. You just had to be able to interpret this one carefully. You could probably do the shell method, but it's a little more complicated because this is given as r as a function of h. So just interpret it like how I did over there. And then you can use the this method. Okay? Please give this video a like if you found it helpful in any way. And hopefully I'll see you in another video as well. Bye.